In most math classes you take, eventually, they're going to have you try and solve some story problems using the math that you're learning. That's going to be the case here. So you're going to be given a few problems to solve where the problems are based on having some kind of a right triangle. Now the reason we're able to solve it is because we've learned how to use these trig functions based upon a right triangle. So let's just review it quickly, even though so say for instance this was an angle and just for fun, let's say this angle was 25 degrees and you knew that this side of the triangle was 10 and they wanted to know how long this side of the triangle was. Matter of fact, we'll call it x. Well, now with trig functions, we can apply trig functions to right triangles to pretty easily solve this problem. We've done this before, but if you recall, the way you do it is, if this is my angle, I think to myself, this is the opposite side of the triangle. I'm trying to determine this side, which is the adjacent side of the triangle. And then I ask myself, of my three trig functions, which is the one that relates opposite to adjacent? And you should remember that the tangent equals opposite over adjacent. So I'm going to apply that to this problem, and I can say the tangent of 25 degrees equals 10 over x. And now it's a pretty simple math problem to solve for x. I'm not even going to finish this, but this is an example of what we've learned, how trig functions allow us to figure out things about a right triangle. So now here's a story problem I'm going to work. I sort of made up, and here's a picture. Doesn't look too great. I'm not much of an artist, but here's the idea. We have like a flagpole, and then say someone is looking at this flagpole. Turns out somehow they know, or they measure, they determine where they're standing. They're 100 feet from the flagpole. Now when they look at the top of this flagpole, so this is like a sight line, the angle they have to tilt their head, right? If you're looking straight along the top of the ground, your head is sort of straight. But if you look at something high above you, you move your head up. A lot of times I call that the angle of elevation. So it's almost like I'm going to say the angle of elevation is 25 degrees. So this person had to tilt their head at an angle of 25 degrees to see the top of the flagpole. So if this guy, maybe he's in a science class and he was given a project, he was told, how high is the flagpole? How tall is the flagpole? So he measured and moved 100 feet away from the flagpole. Somehow he was able to determine that when he was 100 feet away, he had to tilt his head at a 25-degree angle. So by him knowing those two things, he now is able to determine the height of the flagpole. And he's going to do that by using stuff he learned in trigonometry class. So hopefully you can see here that this basic problem, we can think of it as like a right triangle. This is like our right angle, 90 degrees. This angle of elevation is like going to be, you can think of this as like our theta. This would be the hypotenuse. This would be the opposite. And this would be the adjacent. So for a right triangle, here's my angle. I'm given the value of the adjacent, 100. I want to know the opposite. Well, what's the trig function of an angle that relates the opposite to the adjacent? Well, just like we looked at a few minutes ago, it's the tangent. Because tangent, TOA, is opposite over adjacent. So for our specific problem, our angle is 25 degrees. The opposite side, we don't know the height, that's what we're trying to determine. We'll just call it H for height. The adjacent side is 100 feet. So now I have this little equation. Now if I want to solve for H, which is the height, I need to move this 100 feet in the denominator to the other side. So let me just make room. This is something you learned in algebra. Remember, what you do is if you multiply both sides by 100 feet, then these cancel out. And I can just say H is going to be 100 feet times the tangent of 25 degrees. So now, understanding this trig function as it relates to right triangles gives me a way to calculate the height of this flagpole. So I go grab my calculator. So I'm in the degree mode. My calculator's in the degree mode. So I'm going to enter 25 and then hit my tangent key. And then times 100. And for this problem, they asked me to round to the nearest tenth of a foot, or that means 1 decimal place. So it looks like the answer is 46.6307. So 46.6, do I need to round it up or down? Since the next number is 3, 46.6 should be the answer. So the student was able to determine the height of the flagpole was 46.6 feet. All right, so you're gonna have some homework problems where you're basically given some kind of situation and it turns out it's gonna be in the form of a right triangle, and you can now use the trig functions you've learned about to go ahead and solve those problems.